morning, everyone, and welcome to the fifth webinar in the Net Zero Initiative series. My name is Priya Galketiya, and I'm the project engineer of the Net Zero Initiative at Monash University, and I'll be your host today. Firstly, I'd like to acknowledge the traditional owners of the lands that we're speaking on today, which in the case of our speakers and myself is the Kulin Nation, and I'd like to pay my respects to their elders, past and present. I would also like to acknowledge the traditional owners of the lands where our viewers are joining us from across Australia. So welcome everyone. I think we've got about 50 participants already, and there's still more joining us. So I think that number will increase as we go through. So today's webinar is on the always evocative and currently very topical area of net zero emissions transport. So as most of you know, I'm sure emissions from the transport sector is Australia's third largest and fastest growing source of greenhouse gas emissions. So, of course, decarbonising transport systems will be critical if Australia is to meet its commitments under the Paris Climate Agreement. Many of these solutions that we need to achieve this are already available today, but the pathway to realising this change is a challenging journey, as I'm sure many of you witnessed in the recent climate summit talks. It's definitely one that we have to overcome. So today we'll be hearing from our panel of speakers. We have Reeta Lad from Monash University's Transport Division, who'll be taking us through the work that's been happening to date at Monash University. We'll then have Rachel Lynskey from ClimateWorks talk us through identifying a pathway to achieving net zero transport emissions and how that translated to Monash University's goals. And then finally, we'll hear from Dr. Roger Dargaville, who's the Deputy Director of the Monash Energy Institute and Director of Sustainability Engineering. And he'll talk on impacts of EVs on electricity networks and the importance of a well-articulated approach. For those of you joining us today for the first time, I'll just remind you on the format of today's webinar. The webinar will run for approximately an hour with a presentation from each of our three speakers. And then we'll have a bit of time for Q&A at the end, around 20 to 30 minutes. So Q&A can be engaged through the Q&A function at the bottom of your screens on the webinar. And also you can put up your hands if you'd like to speak to us in person through the webinar. The webinar will be recorded and also available after this session ends under the Net Zero webinar page, along with our panelists' presentations. So with that intro, we'll get things started with our first speaker, Reeta. Reeta has been a transport planner for over 20 years with experience in the UK and in Australia. She's worked at many levels of local and state government and in the tertiary sector, in strategic planning and road safety, and in major projects. Reeta is the manager of transport at Monash University, and her team is responsible for the very complex role of managing and planning all of the transport services across our 4 campuses. The university has been pretty instrumental in trialling new and innovative transport services in the past, such as bike share and car share programs for our staff and students. And I think this will be no different going forward in trying to achieve our net zero goals. Reeta's been heavily involved as well in advocating government for additional public transport services, such as the Clayton campus 601 bus service, which has now become the busiest bus route in Victoria. So, well, Reeta, welcome. I'll hand over to you.
Thanks, Priya. I'll just share my screen. Today, I'll be discussing the context of Monash's transport services and how we plan to move to net zero mobility. Monash University has 4 Australian campuses, serviced by a variety of university-offered transport services and public transport. Our Caulfield and Parkville campuses offer the best access to public transport, and their mode share reflects this. Peninsula has the highest single occupant vehicle mode share of all our campuses, driven in part by the lack of frequent and direct public transport services. Clayton is the largest Australian campus and the furthest away from a metropolitan train network. Accordingly, most of our transport services discussed in my presentation are offered at Clayton and at some of our other campuses. Prior to COVID, 30,000 people travelled daily to our campuses during our busiest weeks. This reduced to 19,000 this year. A significant challenge for the university is to provide access to this many people in an environmentally sustainable way. The university established the Net Zero Initiative in 2017, which initially included targets to reach net zero carbon emissions from energy use by 2030 from heating, cooling, and operation of our buildings. This initiative is now expanding its scope to emission sources such as mobility. So in terms of a pathway to net zero mobility, we have a 4-step plan. 1, to reduce the number of single occupant vehicles travelling to our campuses. 2, by providing a greater number of more convenient, flexible and safe transport options. 3, by making it easier to choose the lowest emission mode of transport through a mobility as a service platform. And 4, by ensuring all services that we offer have the lowest possible emissions. So each year, the university conducts a travel survey to understand modes of transport and travel behaviours. We receive approximately now 9,000 responses to the survey annually. Comparative to the Monash Council, which is the local council of Clayton campus, we have significantly less single occupant vehicle usage. The university has done an incredible job of reducing the single occupant use from 2008 through a number of initiatives and services. We currently have 32% single occupant mode share. And we're aiming for a 20% single occupant vehicle usage. So concentrating just on single occupant vehicles and their emissions, this slide shows some of the services in place to reduce the impact of single occupant vehicle travel. We introduced pay-as-you-use parking last year. This is the most significant project in shifting people away from driving. The university has operated with annual physical permits since the introduction of paid parking many, many years ago. At the start of 2020, we introduced virtual annual permits, and during the lockdowns, worked to move all annual permits to a pay-as-you-use model for parking. Our staff and students now no longer lock themselves into driving for a full year, but instead make a daily choice on their travel modes. The university also has 5 EV charging stations. We have a mix of fast and slow charge devices. Usage of these stations have increased. The data showed that during lockdown, our infrastructure was well utilised. We currently do not charge customers for electricity use. Customers are required only to pay for their parking. Renewable power is used through either our solar or wind farm generation to charge the EV, for the EV chargers. We also offer car share and pool car services to our staff and students. The car share is for personal use, and the pool vehicles are for staff to access pool vehicles to grow into campus and to meetings and so forth. We do encourage staff to use these vehicles with another staff member attending the meeting. We also introduced in 2019 a carpooling app that incentivises people to leave their car at home and come with another person. It offers significant discounts on their parking fees if you travel with 1 or more passengers. This service has evolved over time, where initially 2 people were required to swipe their ID cards simultaneously to gain access through boom gates. Today, passengers ride match through a rideshare app called Liftango. This app matches and validates people's journeys. Once validated, carpoolers receive discounted parking through the university's car parking app. Approximately 3 to 5% of drivers are currently carpooling. The university also has a number of sustainable transport services and initiatives to encourage people to not drive. We have been tireless in our advocacy to the government to provide additional mass transport service options to the campus and the precinct. We successfully advocated for the 601 bus service in 2011. The service operates every 4 minutes between Huntingdale train station and Clayton campus. Since its introduction, it has become the most patronised bus service in Victoria. When it was introduced, we saw a significant shift in bus plus train usage to the Clayton campus. We also advocated for improved infrastructure at Huntingdale train station to make catching the bus safer for the thousands of people catching the train and bus from Huntingdale. More recently, the Victorian government has announced a suburban rail loop and train station at Clayton campus. This is seen as a transformational transport service, not only for the university, but for the surrounding precinct. This will be a significant contributor to reducing single occupant vehicle travel to the precinct. On top of the public transport services, the university offers its own shuttle bus service that runs between its major campuses. This is one of the busiest chartered services in Victoria. In the next couple of years, we'll be looking to partner with a provider that operates low emission buses. On our campuses, we also build infrastructure that encourages active transport. We have 2 bike arrival stations at the Clayton campus and bike cages at each of our other campuses. On our campuses, we actively prioritise cyclists and pedestrians by including bike lanes, pedestrianising our campuses, and shifting car parking to the corner of our campuses. We've also in the past provided share bike services. This was a highly successful program that assisted many of our residential students. We also trialled electric scooters in late 2008, which created quite a buzz on our campuses. We look forward to changes in current legislation, which make operating electric scooters in Victoria quite restrictive. So as you can see, the university offers a range of transport services. We are still looking, though, to increase our offerings to include the return of micromobility to our campuses, which is not only challenging through restrictive legislative requirements, but also in a COVID environment. People aren't willing to really share mobility services. Also, the operating model would be quite hard to implement right now. We're also looking to expand our car share offering so that customers can use one service for business and business and personal travel. And with this, we'll be looking to implement electric vehicles. We would also like to implement low emission shuttle buses in the form of electric or hydrogen fueled vehicles. We're also looking to implement technology for our shuttle bus services, which are currently just a fixed timetable, but technology which will allow people to book their bus, but also the technology could be used for on-demand shuttle services so that we can scale up or down services based on demand. We're also looking to trial on-demand services to areas currently with high vehicle usage. As you can see, we operate many services and are looking to expand this. Each service currently operates with its own customer interface, and customers cannot travel plan or compare services based on travel time, cost, or environmental impact. The introduction of Mobility as a Service platform will assist our customers with journey planning and will help prioritise low emission mobility through greater customer insights from aggregated data. Thank you for taking the time to hear about Monash's journey to net zero mobility. We believe by making transport services more flexible and convenient, our campus access system will be well positioned to achieve net zero emissions.
Thanks, Rita. Thanks for that. I guess it always amazes me being a recent, employee at Monash, only being Clayton in the last few years, how many people travel to our campuses. And I think it highlights the role that Monash can play in demonstrating net zero transport solutions. So thanks, Rita. Next up, we have Rachel Lynskey from ClimateWorks, who will talk us through the next step that Monash University will be taking through the Net Zero Initiative. Rachel works in the Cities team at ClimateWorks Australia. The Cities team focuses on facilitating policy shifts and embedding net zero emissions pathways in key infrastructure, in key sectors such as transport and infrastructure. Rachel brings a passion for climate action along with a practical understanding of how transport networks function and the policy implications for reaching net zero emissions in this sector. Prior to joining ClimateWorks, Rachel worked with a number of organisations establishing grassroots campaigns such as the Sustainable Cities campaigns for Friends of the Earth and peak advocacy groups in transport. Her passion for driving climate solutions began through her involvement in the COP21 Paris climate talks for the Australian Youth Climate Coalition. Welcome, Rachel. I'll hand over to you.
Thanks, Priya, and thanks for sharing what's already happening at Monash, Reeta. Yeah, good morning, everyone, and thanks for the opportunity to share the work that ClimateWorks has done on net zero emission mobility options for Monash's, particularly Clayton campus. The report that we brought together in early 2020 was drawn from the national level work that my team does on addressing emissions in the transport sector. So I'm really excited to share what those opportunities were and some of the case studies that Monash Uni can draw on to extend the work that Reeta has already spoken to. For those of you who aren't familiar with ClimateWorks, we're a not-for-profit based out of Monash University's Sustainable Development Institute. And as Priya flagged, we conduct research and provide advice on accelerating the transition to net zero emissions in Australia and Southeast Asia. I particularly work in our cities team, which focuses on the transport, building, precincts and infrastructure sectors. And so why are we talking about transport in particular? Why is it such a passion of mine? Well, as we can see, transport has been and continues to be the fastest growing and third largest source of emissions in Australia. In particular, the Australian transport sector lags behind a lot of other parts of the world. Our road vehicle fleet is particularly energy and emissions intensive, and things like our per capita aviation emissions have been some of the world's highest. So there's a really urgent need for Australia to up its game. In particular, we can see other countries making more ambitious commitments recently, with the USA committing to only having electric government fleets, including their postal service and school buses, and other countries like the UK banning the sale of petrol and diesel vehicles in the near future. It's also a sector that has seen huge disruption through COVID over the last 12 to 18 months. And really, seeing that opportunity of disruption as an opportunity to ensure that the sector doesn't return to its high emissions activities, unfortunately hasn't been realised. The most recent data is showing that emissions have in fact returned to those pre-COVID levels, suggesting that there's still lots more work to be done. So what would a zero emissions transport system look like? The report that we did for Monash University's Net Zero Initiative on identifying net zero mobility opportunities for Monash is an application of our national level work that my team has been undertaking. Last year, we published the Moving to Zero report, and we were developing this report at the same time that we were working with Monash University on their net zero mobility opportunities, which meant that we could really apply a lot of the research and literature and case studies that we were exploring. Moving to Zero provides an extensive survey covering the broad remit of the transport sector, including both passenger and freight transport, different modes, including road, rail, aviation and shipping, and really sought to bring the whole sector together and showed that the sector is really ripe for transformation. There are a lot of established opportunities that would reduce emissions in the transport sector. Moving to Zero outlines what these opportunities are and the steps that can be taken. And by taking this evidence, we can really see that there's a lot of influence that Monash University can have and leadership that they can be showing in the transport space. To be an exemplar of net zero emissions, Monash University has a huge amount of potential. We know that universities play a vital role in both educating and demonstrating climate solutions. The size of Clayton's campus, as mentioned, the scale of movement means that there's really an opportunity to test changes at that scale. The location in suburban Melbourne, with comparable accessibility challenges to many other precincts in urban Australia, mean that the learnings that can be taken will really apply across a lot of Australia. Monash can test and demonstrate these solutions, embed it in their research and the core of what the university is there doing, and provide that evidence for the broader Australian community to look at what the options are to transition to a zero emissions mobility system. There's also an opportunity to inspire those who are using the campus and give students and staff and visitors a first-hand experience of those zero emission solutions that could set their travel behaviours and provide reach back into their own networks and their own communities, spreading the impact well beyond Monash University. So what are the opportunities? We really see that Monash Clayton as a precinct can become a vibrant, diverse and connected precinct through net zero mobility services and infrastructure. By shifting the network to net zero emissions transport, we can provide convenient and cost-effective transport options both on and around campus to make it a seamlessly preferred choice for staff, students and visitors. ClimateWorks in particular recommended that Monash University prioritise actions under these three themes, which align with the work that we have been doing at that national level. The first theme is really around having those high-level strategies, planning and frameworks that align with net zero transport objectives. An action under here that we saw as really crucial is around building a diverse coalition of supporters that Monash sits within a precinct with other businesses and research institutions and many other residents, and that these people can be part of building the, sharing the vision of moving towards zero emission transport. The second theme is really around shifting our transport networks to more efficient and shared mobility modes with the right infrastructure services and pricing mechanisms. As Reeta spoke to, mobility as a service, for example, is an action, integrating to enable users to connect to a range of transport options with a consolidated pricing model that incentivizes people to use lower emission options. And the third theme is really around improving our vehicles to make sure that, when we do need to use them, they're running at zero emissions. And I think that Monash in particular has a great opportunity to tap into the research that's being done on transport fuels and different technology and different business models that will be part of the zero emissions transport mix going forward. And now I'm just going to share some case studies that can kind of bring some of these recommendations to life and talk to how they could apply to Monash University. So the Stanford University is a great example of how they had that high-level strategy and had to develop a plan on how to reach zero-emission transport objectives. They had come to an agreement with their local council around opportunities to construct new buildings and campus facilities, but this was only going to be possible if the council required them to the benchmark was defined as no net new commute trips. So given that often building new facilities or enabling more activities to happen on campus, that generally generates new visitors and more activity on campus. So they knew that without active interventions, congestion in the area would grow. The achievement of this requirement was not purely based on transport initiatives. They really sought to change how the broader campus operated through a community plan that involved compact land use development that could promote public transport use and cycling and walking. They did things like work with other local stakeholders to fund bikeway improvements, connecting people into campus. And they implemented many practical strategies such as, free shuttle bus rides between campus and the local train station, cash incentives for staff and students who are off campus if they didn't buy a parking permit, behaviour change programs that could shift their driving times to off-peak and reward those who walked or cycled to campus. And as you can see in the graph here, in 2016, commuting by car had reduced to 43% when it had begun at 69% in 2003. I think in terms of the lessons that, Monash as a university can draw from this is really taking away that partnership approach that Stanford University used. They had to work with the local council to both meet the university's goal of buildings growth, but also support the council to achieve their objectives around reducing congestion. And as we know here in Melbourne, including the local Monash Council that the Clayton campus sits with has objectives around addressing climate change, and there could be opportunities to work together on achieving those joint outcomes. Other stakeholders in the precinct can also enable those initiatives to thrive and build that demand. There'll need to be work with public transport operators and policy makers and program designers to enable these improvements. And again, Monash can really build on these opportunities that will both meet emission reduction targets for everyone involved by taking that partnership approach. Under the next theme, we can draw on this case study around how pricing mechanisms have been used at other universities to shift transport mode choice, and in particular, the use of a lot of these programs across North America that provide fare free public transport access, established by universities and public transport agencies together to generally reduce congestion around campus and improve air quality. This particular case study from the University of California in Los Angeles is in a city that's generally perceived to be have a lot of urban sprawl with high car dependency and pretty poor air quality as a result from those cars. But UCLA brought in some subsidized public transport passes based on the fact that their cost-benefit analysis showed that it would have a positive benefit to the uni. It initially began with just one transport agency connecting into the campus, but has now expanded to cover more public transport options around Los Angeles. The program's seen increased public transport use and continues to reduce car trips to campus, but also beyond campus trips. It also saw public transport use grow with students using the passes to travel to work or jobs or recreational use, which really shows the influence that this can have on behaviour beyond just their university commuting. In terms of bringing these learnings to life for Monash University, there's many transport options, as Reeta's outlined, that connect both staff and students and visitors into campus, including the local bus, the inter-campus shuttle bus, e-scooters and bikes, carpooling, the government announcement of the suburban rail loop project, the change to parking system pricing. And given so many options, it's really important we consider how these could be offered through an integrated service, such as mobility as a service, and importantly, how pricing of those mechanisms need to then factor in the emissions impact of different modes and provide the right signals to focus on zero or lower emission options. And finally, the electrifying your bus fleet. Here we really looked at how we can improve vehicles to be running at zero emissions, particularly given that Monash is only accessible by bus at the moment in terms of public transport. The city of Shenzhen in China have electrified over 16,000 buses in their fleet over the last 8 years, both to reduce emissions, but also address air and noise pollution and provide the reduced whole of life operation and maintenance costs that come by switching to electric technologies. The fleet transition was enabled by both policy direction from their their city government, as well as national and local government subsidies, leasing arrangements that brought down the cost with manufacturers working with the city, and rolling out more charging infrastructure so that the network could run smoothly. A key learning was around that they developed a lot of local capabilities and expertise in this electrification that have been able to then be applied to other cities in China and around the world, and to other mobility modes, such as they're transitioning their taxi fleet now to provide them as all electric vehicles. So for Monash, and particularly the Clayton campus, the electrification is a key element of moving to a zero emissions mobility network. And I think Roger will be speaking more to some of those opportunities just after me. But those opportunities are arise across a number of areas. So firstly, as Reeta identified, the 601 shuttle bus between the closest train station and campus is one of the busiest bus routes in Victoria, coming every 4 minutes at peak times. Many of those other public buses in the surrounding suburbs are less direct or less frequent and see much lower patronage. And I believe Monash University even sees higher numbers of parking permits being purchased by people who live in those suburbs. So it could be a really exciting opportunity to work with local operators and government to both improve the patronage on these routes by Monash, sharing the data and those recommendations, and also advocating to shift them to electrified buses, which will enable even greater numbers of staff and students to have access to a zero emissions transport option to campus. There's also the intercampus shuttle bus, which has direct procurement control of Monash University. The university can invest in the infrastructure and change that to a zero emissions transport option. And finally, as mentioned, the local capacity that can be built through this. For example, in things like vehicle design, local bus manufacturer 𝗗𝗲𝗿𝗀 is based in Dandenong and have recently launched an electric bus that came from a partnership with Monash University's Mobility Design Lab around designing that bus to really suit Australian needs. So let's keep building on this wealth of knowledge that Monash University holds to keep developing our local capabilities in zero emissions transport. And finally, while the recommendations that we have put to Monash University around the need to address transport emissions resulting from our mobility activities, there are also many co-benefits for the university. The case studies chosen often had different driving factors behind their implementation, such as air pollution, cost saving, economic growth, and Monash can really tap into these widespread benefits as well, particularly in light of COVID, where the higher education and transport sectors have been heavily impacted. It's given us the opportunity for a conversation about these changes. Monash University can really demonstrate the possibilities in rebuilding Australia in a post-COVID world, building in resiliency and flexibility for the university. Thank you all for your time, and I look forward to your questions at the end.
Thank you, Rachel. Lots of opportunities there for us to implement solutions that are targeting those transport emissions. But as you say, it really presents an opportunity in the precinct as well, I think. And for some of those of you joining us who might not be aware of the Clayton campus is, in the heart of what's designated as a technology and innovation precinct in Victoria. And I believe it's the second biggest employment region outside the CBD. So there's definitely a lot of key stakeholders in the precinct. And I think it's been heartening to see after the initial work that Rachel and her team have done that the initial engagement has been seen some very enthusiastic response from those stakeholders. So just a note that we're getting lots of questions come through on the Q&A feature. So thanks a lot for everyone who's putting those through. We'll respond to some of you via the chat, but also we'll be saving some of those for the Q&A session at the end. But please keep putting your questions through on that feature. Rounding out our speakers today, we have Dr. Roger Dargaville. Roger will provide some insights on the leading research into electric vehicle impacts on grids, and which is, of course, a significant challenge on the road to net zero emissions. Roger is an expert in energy systems and climate change, specializing in large-scale electrical energy system transition optimization, as well as established storage technologies. Roger researches the viability of novel energy storage technologies such as seawater, pumped hydro, and liquid air energy storage. Lots of very exciting, future solutions for us. Roger, I'll throw it over to you. Thanks.
Great. Thanks very much, Priya. It's an absolute pleasure to be here, and thanks to my colleagues, Rachel and Reeta, for their presentation so far. I'm going to shift gears a little bit and talk about very large-scale impact of EVs on the grid. So we're not looking just at Monash campus, we're looking at the entire East Coast grid in Australia now. This plot shows the projected EV fleet for 5 different scenarios from the Australian energy market operator under a project they call the Integrated System Plan. And what you can see in this plot is there's a lot of difference between these different scenarios. In the blue scenario at the top here, which they call their step change, we're going to be hitting 30 million vehicles. So that's more vehicles than we currently have on the road by 2050. So that's, as the name suggests, a big difference. But in the much more modest, slow scenario, by 2030, we still don't have hardly any EVs, but we do get up to 5 million by 2050. So the answer, the reality probably lies somewhere between these, or maybe even slightly higher than the step change, depending on how things go. But we're looking at, I'll show you some numbers, assuming that we hit about 5 million vehicles in sometime in the next 10 years or so. Trying to understand what the impact of EVs on the grid is not easy. To start off with, there's lots of different ways that EVs can draw power off the grid. They can be as little as 2 kilowatts. If you can plug an electric vehicle into a regular power point and draw 2 kilowatts, which is the same as, for example, an oven or an air conditioner would draw. So it's not an insignificant load. You can install a 7 kilowatt charger in the home environment. So that's significantly larger. So you're now looking at quite a large draw. 22 kilowatts is possible at public charging stations on an AC grid. And then you can go to DC fast chargers, which range from 50 up to 350 kilowatts. So you can see this range of 3 orders of magnitude or 2 orders of magnitude is really significant. And so answering the question of what the impact of EVs on the grid will be depends on what kind of chargers we'll be having EVs plugging into. It also makes a difference because the DC chargers can be connected directly into the medium voltage network, whereas the 2 kilowatt chargers are going to be in the low voltage distribution parts of the network. So the overall impact is also quite difficult to work out. But if we just look at a fairly large scale example, if we look at the possibility that we have 5 million cars plugging into the grid in the early evening and simultaneously charging, and 20% of the cars do that at one point in time on a 7 kilowatt charger, that's a cumulative total of 7 gigawatts instantaneous demand in the early evening. If we see EVs charging like this, it would be an absolute disaster. And I'll show you graphically what that might look like. So this graph here shows you the energy demand and generation for a 24-hour period from last week for the national electricity market, which is the 5 eastern states in Australia. And in the graph here, you can see from 24 hours period, we have a minimum in demand at about 4 o'clock in the morning. In the early morning, it ramps up. We have a peak at around about 8 a.m. The demand actually gradually decreases during the afternoon and then ramps up to the maximum for the day at around about 6 p.m. in the evening. We've got our brown coal generators in Victoria, black coal generators in New South Wales and Queensland, gas in the grey here, hydro in blue, green is the wind farms, yellow is the utility scale PV, and the slightly duskier shade of yellow here is our rooftop PV. So there's a lot to note here. Rooftop PV is enormous at the moment. On this particular occasion, it was the largest generator after black coal, so even beating out brown coal. So the solar rooftop revolution is certainly well underway. If you take out the solar, then we're seeing quite a significant dip in demand from our traditional generators. This is known as the duck curve. You can kind of imagine a duck's neck here, which is a significant problem in the grid. If we were to charge 1 million EVs or 20% of a 5 million EV fleet, and they all came in and plugged in the evening, or most of them plugged in the evening, you can see we have this big increase in demand in the early evening. This would be very difficult to manage. It would require building significantly larger generation assets, and it's happening after the sun is set. So it's very difficult to, you couldn't meet it with solar, you'd have to build other generation capacity. So one thing we really don't want to see happening in the grid is that all the EVs are just plugged in the early evening when drivers arrive home and drawing that power off the grid. An alternative is that we have nighttime charging. And in the current energy mix, this would tend to make sense, that we have low demand at 3 o'clock in the morning. And so if most of the EVs could be charged during this period and have that charging spread out over a longer period, then it has less of an impact on the grid. But it's still at a time of the day when we can't meet it with PV, which is obviously the most popular generation type on the grid. A third option is that we have EV daytime charging. Now, this looks challenging because it's increasing the peak demand, but it perfectly overlaps with the production of PV power. So by ramping up the amount of PV installed in the grid, this extra demand could be met relatively easily. The final result, of course, will depend on what all the generation mix underneath this curve actually looks like. And in the future, we're very hopeful that this will change. It's almost inevitable, of course, that we will shut down black coal, brown coal fired power stations. So the mix of renewables will look quite different. And what you really want is a flexible system where the EVs charge based on the availability of renewable energy. So some of the charging would be daytime, some would be nighttime, and you want a system that can adapt and be flexible. So as I said earlier, if we do the planning for EV charging badly, it will be a disaster for the grid. We'll end up with higher energy costs and a less efficient system. If the EV charging is done in a smart way and it's flexible, then we'll have a much more efficient use of the energy system infrastructure. So better use of high and low voltage distribution systems, better use of the generation capacity available. This will result in lower energy costs for everyone, not just the EV owners. This will require, and there's a lot of challenges to actually get to this vision, standards for charging stations where we have software and communications to the market operator that will facilitate that response of EV charging to the availability of energy on the grid. We want the charging patterns to follow that availability of renewable power on the grid. And if we can do that, then EVs actually become a net benefit on the grid, not just a major impact. So I'm going to leave it there to allow lots of time for question. Priya, back to you. Thank you.
Great. Thanks a lot for that, Roger. A lot of challenges for the grid as we transition today. So thanks everyone for and thanks to all the speakers for that content. We've had a lot of questions come through. Roger, I might stick with you to open the questions. And I think a topical one that we discussed briefly before we went live is one that's been posed by Wendy. Is there a view on EV tax being introduced by the Victorian government? And I think that's one that I think quite a few members of the audience would be interested in, given recent activities.
Certainly. Thanks, Priya, and thanks, Wendy, for the question. So the Victorian government has proposed a road use charge for electric vehicles. The logic being that EVs don't pay for fuel, for petrol or diesel, and so they're not paying the fuel excise, which in theory at least pays for roads. The policy is of course flawed because the fuel excise doesn't pay for roads. Roads come out of general revenue. And of course, we don't want to disincentivize EVs because moving away from fossil fuel power cars is important. But it's not cut and dried, because if you do have a large uptake of EVs, then that revenue source through the fuel tax will go away. And if the excise was working properly and it was being used to pay for roads, then that would be a problem if that excise reduces. So I think what you need is a user pays system where drivers do pay for using the roads, but it needs to be sophisticated. It needs to target congested areas. You don't want a system, for example, where rural drivers are charged as much as city drivers for using roads where congestion is not a problem. And you want to incentivize EVs as well as having a road use charge, but you should do that at the point of sale when people are buying EVs, because the biggest barrier to buying an EV at the moment is the much higher upfront cost. So I think the logical thing is to have a user pays road system, but with incentives to decrease the cost of EVs in the first place.
Thanks, Roger. And just staying on electric vehicles, but moving into buses, Roger, just a question from Nicole on barriers to locally electrifying the bus fleet. I mean, you talked about EV cars and the impact on the grid. You know, we could obviously safely assume that there's going to be significant impacts with EV buses coming on at those depots and the grid being able to supply them. Are there any other barriers to locally electrifying the fleet?
The electric buses are a really interesting area. They're actually, I've been on trial in Melbourne. There are a couple of bus lines have got EVs, electric vehicle buses running on them. The challenge with buses is they tend to run all day. They do quite long distances. And so the vehicle needs a lot of range, and that means the batteries are expensive because they've got to be quite big. And then when you return the bus to the depot and you're charging it, if it's just one bus, it's not too bad. But if you had a whole fleet of buses, you're talking about a massive draw on power off the grid. And so the bus depot actually needs to be on the high voltage part of the grid to be able to manage that. If you just put it into a standard substation, it wouldn't have the capacity. So you have to start thinking about the design of the bus networks and where the depots are to be able to facilitate high uptake of electric buses. But as I said, they are underway. They exist in other cities, as Rachel was discussing. So the barriers are not insurmountable, but they're not tiny either.
No, I totally agree. Thanks, Roger. We've got one here that's a bit more specific to Monash University and ClimateWorks to an extent. And Reeta, you might be able to help out with this one on the work being done on the fleet vehicles and providing zero emission vehicles. I know we're looking at some of that, those contracts at the moment, and I guess it'd be also, I think, good to sort of highlight some of the work being done with some of the other vehicles that access our campuses, such as the waste services and the buses. So maybe you could give people an idea what's happening.
Yes, so we're looking currently to expand our car share services. We currently have a small fleet provided by a couple of organisations, and these are currently traditional vehicles. But in the swap across or expanding these services, we are integrating into our contract or our specifications that the requirement to transition at some point to electric vehicles. It is something that in the operation team that requirements for any of our vehicles that are operating on campus, so like your maintenance vehicles, that there is a plan in place that we will see a transition across to vehicles with lower emissions. So that's just through all our specifications and our contracts moving forward in line with the plan.
Yeah, and I know that some of the recent work done on hydrogen really highlighted, use cases such as waste services, which are really energy intensive, being possible solutions where we can shift those vehicles that are pretty high emitters as well. So that's been some interesting work done within at Monash. Just wanted to throw over to Rachel and some of the impacts we're having with COVID. You mentioned in your presentations with numbers, transport numbers going back to pre-COVID levels. Can you just maybe expand on that and just what the impact COVID has had on transport data?
Yeah, indeed. It's an evolving situation and certainly an exciting unexpected opportunity that has arisen in the transport sector, in that we have seen huge disruption and that the normalisation of working from home and reducing the amount of travel demand that we have on our system, has presented the opportunity for emission reductions, and hopefully embedding that in a more, everyday sense can mean that there is, less congestion across our network and less emissions across the transport sector. The other side of it is that we are seeing data that shows that people, are hesitant really around returning to shared transport options, be that public transport or, as Reeta flagged, around those kind of shared bike or, micro mobility options, and instead replacing some of those more of those trips with private vehicle use, which will cause, real issues if we see that growing demand on our road network that already, was pretty capacity, at its limit with congestion, and certainly, coming into major areas like the city or, where major destinations are like Monash campus, that we really need to look at, well, what are the other options and how can we, rebuild that public trust in using shared public transport modes. And we're starting to see, the emissions returning again, unfortunately. But Monash has, built certainly in our education and research capabilities around, using online methods to do things like host webinars and do work from home. And we've really shown that we can learn from these kind of crises and implement them in a more long-term way. So I think there's real opportunities to draw on there.
Great. Thanks, Rachel. And we've had a question come through that you might be able to comment on about support for clean air zones with areas in the UK adopting clean air zones in areas such as London and Birmingham. Is this something that is feasible in Australia? Yeah,
great question. I guess there's a suite of issues, a suite of solutions that we can be drawing upon. And it kind of speaks back to the commentary around electric vehicles and, how we're kind of shifting our vehicles to cleaner and zero emission options. And the research that ClimateWorks has done, an analysis around achieving net zero emissions by 2050 has shown that 50 to 75% of new vehicle sales need to be electric vehicles by 2030. At the moment we're less than 1%, so that's a huge increase in scale of the need to ramp up vehicle sales in order to meet those targets. And we're going to really need a suite of solutions and things like incentives and changes to how our city looks and how it's designed to both incentivize bringing those vehicles into our car fleet so that they meet, whatever the regulatory requirements are, is a really important part of that, as well as, having the infrastructure that can support that, having the education. And as the current conversation around pricing is kind of sparking or highlighting the gap of those other elements, that if we could just look at, taxing things as we move to a new pricing model, then we're kind of missing a whole bunch of the other bits of work that need to happen to really, incentivize and encourage more vehicles to get on the road here in Australia and be zero emissions.
Thanks, Rachel. I've got one for the whole panel here that would be, I think, an interesting one from 𝗗𝗲𝗿𝗀. It's in relation to mass and e-bus service models where businesses provide the subscription model. What sort of barriers do you see in these businesses being allowed to lead the way to enable, greater adoption of these solutions? Maybe Reeta, maybe you could provide some comments based on the experience you've had trying to implement some of these services.
So this is about the businesses helping bringing the cost down for the customer.
Yeah, and how does what are the barriers for mass being adopted by the end users?
I don't see there being great barrier to the uptake of MAS. You know, we do see a lot of customers use transport apps. I mean, at the university themselves, we've got 5 or 6 that we're currently offering. And you know, the barrier to using them currently is that they don't integrate, and they can't tell you what is your multimodal journey that you can take. So providing a MAS platform, you know, the barriers come from, you know, will companies integrate into a greater platform? You know, what happens with the data sharing? Is one company prioritized over another? They're the kind of barriers, but organisations providing funding so that we can provide subsidised transport is welcome, but it does provide an advantage to that organisation over some of the others, which would be a barrier.
And Rachel, you flagged a similar, I guess, services being adopted outside of Australia. Were there any major barriers identified in any of those case studies?
I can't recall specifically around barriers, but I guess a clear way that you can often overcome barriers is by having that high level signal. And so having that signal from Monash about that commitment to, working with a range of companies and businesses that can provide those solutions is really, important to signal that demand. And then, businesses can come and meet that demand if they see that the appetite is there, and that, there's a willingness from the university to work together in resolving what specific barriers might be, specific to somewhere like Monash and the challenges that the campus there faces.
Great, thanks. And we're quickly running out of time, so we've got time for one more question. I think as we look forward, it'll be good to get a response on this from you, Roger. It's on the view of how vehicle-to-grid scenarios can help rather than disrupt grid stability, because I guess as the EV transition occurs and we move to having more accessible vehicle-to-grid charges across our network, how that will affect networks.
Yeah, thanks, Priya. It's a great question. I saw a couple of different people had more or less the same question. I didn't get to this in my talk in the interest of keeping it brief, but it really is a very important component of electric vehicles. If EVs plugged into a charging station can return that electricity back onto the grid, they can effectively become a peaking power plant. And at the same time that we look at the potential problem of 7 gigawatts being drawn off the grid simultaneously from 1 million vehicles, you could potentially put 7 gigawatts onto the grid from those same 1 million vehicles. So they can act as a replacement for a gas peaking plant. And so we can solve a lot of grid stability problems and the variability in renewables through having that service provided by the EVs. The challenge is having the EVs plugged into the right part of the grid. And you can imagine in a high renewables, high solar world, we want to charge the vehicles during the day, but it'll be the evenings when we need that power back on the grid, and the vehicles are probably not in the same place. So you've got to double up on the charging infrastructure. Whether that happens or not, we'll sort of wait and see. It's still early days. The penetration of EVs is so small at the moment, it doesn't make hardly any difference. But if we don't plan for it properly, then we're going to be in a world of pain in the coming decade or so.
Great, thanks. Lots of challenges, but definitely I think something that that can be addressed. So thanks to all the speakers today. We've run out of time today. And thanks for the participants' questions. They've been great. I think it's generated a lot of discussion, and we'll try and get back to some of you directly as well on some of those other questions. There is a survey that's just been shared, so if you can take a couple of minutes and complete that survey, it'll help the Net Zero team work out what would be of interest for you to see in the next coming up webinars. So thanks to all our team, Roger, Rita and Rachel again, and also to Karen and Nancy, who've been working furiously in the background to make things go smoothly. So thanks, everybody.